Okay. Centripetal force which is by default, which is acting, or which is, you can say, directed towards the center of circle. So there must be the centripetal force. This word is extremely important here. It must be acted upon by the centripetal force, which is directed toward the center of the circle. So here you should write down the centripetal force instead of just the centripetal. Okay. Now the part B of the question. The weight of the airliner is 1.2 into 10 to the 6 Newton, and there is the aerodynamic lift force of 1.39 into 10 to the 6 Newton acting at 30 degrees to the left of the vertical. By drawing a scale vector diagram or otherwise show that resultant of this force is in the same direction as the resultant force we drew in part A. So here you can see either by using the vector diagram or by using the calculation. Otherwise, we can show this using the calculation. The resultant force is nothing but the resultant force which is acting in the same direction that we had seen. We had drawn here, which is directed toward the center of this imaginary circle, that is toward the left hand side. So we can do it in either way, either with mathematics or with the vector diagram. So here I will show how we can show it with the vector diagram. But before that, we need to know how we can identify or we can show the resultant force in terms of the vector diagram. So for that, we can use either the triangle law or we can use the parallelogram law. So here you can see this is the triangle law of vector addition. It is called as the triangle law of vector addition, and this one is called as the parallelogram law of the vector addition. Okay, so using either triangle law or parallelogram law, we can show the resultant force vectorially. So first of all, you can see here we have the two forces acting over here, which are nothing but the two vectors. Force is nothing but the vector. So we have to apply the vector algebra. For that, we have two laws of vector addition: the triangle law of vector addition and the parallelogram law of vector addition. So here you can see this. Suppose here A is nothing but the vector and B is nothing but the vector, and we need to find out what is the A plus B. What is the A plus B? That is addition of the two vectors. Because resultant is what? Nothing. Resultant force is nothing but addition of the all the forces. Okay, and force is nothing but vector. So here we need to understand the vector diagram. So here, what is the vector? First of all, vector is this arrow is showing the direction of the vector, and this length of the vector shows the magnitude of the vector. That you should always remember. So length is showing the direction of the vector, and this arrow is showing the direction of the vector. So if there is a suppose two forces here, suppose this is a force of 1 Newton acting in the directed towards the right hand direction. If I want to show the force of 2 Newton, then what I should draw? I should draw the line double to this original line. Okay, this will be the 2 Newton. Okay, so this line is showing the magnitude of the vector. So if this is 1 Newton force, it is suppose 1.5 centimeter line, then it is a 2 Newton force, it should be the 3 centimeter line. Okay. So that line is showing the magnitude of the vector, and arrow is showing the direction of the vector. So here you can see the vector A is drawn like, suppose it is directed towards the point B here. I will say this is the tail of the first vector, and this is the head of the vector A. Okay, and here this is a vector B. I can say this point B is nothing but the tail of vector B, and C is nothing but the head of the vector B, because it is directed from point B to C. Okay, it is moving in this direction, B to C. It is moving from A to B. That's why it should be the tail of first vector, head of the first vector, and B point should be the tail of the first vector, and C point should be the head of the second vector. So when once you draw a vector like this and we are connecting here head and tail, we are connecting here head and tail of the two vectors. Okay, then we can consider this as the first side of the triangle, and here we can consider as the second side of the triangle. You have to just connect their head and tail, and then you have to just simply draw the third line. This will be automatically the addition of the two vectors. So here you can see it is nothing but the a plus b. Okay. So C is starting from the tail of first vector and ending at the head of the second vector. This direction is extremely important. You have to draw always from the tail of the first vector towards the head of the second vector. So this third line itself is the addition of these two vectors. Okay. So vectors can be anything, it can be force, acceleration, or anything. The second law is nothing but the parallelogram law. It is nothing but the same thing. See here, this is a vector A and this is a vector B. If these are the two vectors, and suppose this is the tail of the first vector and this is the head of the first vector. Here vector B, this is the tail of the first vector and this is the head of the second vector. Okay. So here what is we are doing? We are connecting their tails and tail. Okay, we are connecting their tails and tail. So this is the first, we can say first side of the parallelogram. This is the second side of the parallelogram. Okay, so here we are just drawing the parallel line to this second line. So I can say it is 2 dash. 2 dash is nothing but the exactly the same parallel line to second line, and this is the 1 dash, which is nothing but the parallel and identical to this line A. Okay, so why we are drawing 2 dash and A dash? Because we need the perfect parallelogram. Okay, so now here we can say the vector going from A to C, which is directed like this, okay, which is coming from the tail of the two vectors and going towards the another point of the parallelogram. So this is nothing but the addition of this two vectors, that is nothing but A and B. Okay. So what we are doing over here basically in the triangle law and the parallelogram law. In the triangle law we are connecting the head and tail of the vectors, and in the parallelogram law we are connecting their tails. Okay. If you connect head and tail directly, we will get the third side of the triangle as the resultant. And if you connect the tails, okay, then the parallelogram diagonal is nothing but the A plus B. Okay. So because when we connect their tails, we need to draw another two lines here which are parallel to this A and B, and then only we will get this perfect four lines of the parallelogram, and then vector coming from this tail junction, or we can say intersection, tail intersection towards the other side is nothing but the addition of these two vectors. So either you draw with the triangle law or you draw with the parallelogram law. Only the difference is that here we are connecting head and tail of the vectors, and here we are connecting tails of the vectors. When we connect head and tail, third side directly is the addition of the vector, and when we connect tail and tail, we have to draw the two additional lines to make the parallelogram, and the diagonal is nothing but the addition of the two vectors. So here what I will do here, I need to first understand what should be the magnitude of the those two vectors. Here the two vectors are there. The first vector is nothing but the weight of the airliner, and second vector is nothing but the aerodynamic lift force. Okay. The forces are nothing but the vectors. So first force is weight, which is acting on the airliner, and the second force is aerodynamic lift force, which is acting on the airliner. So first force magnitude is given, that is 1.20 into 10 raised to 6. Second force magnitude is given, that is 1.39 into 10 raised to 6 meter. So this, as I told you before, in the vector this line is telling you the magnitude and arrow is showing you the direction. So this numbers, they have given the numbers. These numbers can be used directly for the calculation, and also for drawing the vector diagram. These numbers are useful. So in the rough calculation you can do here, I can write down like the weight is nothing but the airliner lift is is nothing but 1.39 into 10 raised to 6.